Hello, you are welcome to Chris Control Automation. In this video, we are going to look at how to use Inductive Proximity Sensor to stop an induction motor. This circuit is most useful in the industries where a metallic object will be conveyed by a conveyor. So when the metallic object reaches where the inductive proximity switch has been positioned, it senses it and then it stops. The moment the operator picks up the metallic object, the conveyor will start again and then it will continue to run until the next metallic object. So we are going to do the wiring and then we see how it will operate. This is the circuit diagram. The sensor is a 24 volt DC sensor. So we have our 24 volt DC here. Okay, this is selector switch. The sensor has 3 cables coming out. We have the brown cable, that is the positive. We have the black cable, that is the positive output. And then we have the blue cable, the negative. This is the brown, the black, and then the blue. This is 24 volt DC supply. From the positive side, it comes to one side of the selector switch. Now, from the other side, it connects to the brown cable of the sensor. The black cable from the sensor goes to terminal A1 or 14 of the DC relay. You connect negative supply to the blue cable of the sensor at the same time to terminal 13 or A2 on the relay. From the AC source, you connect the live to one side of this normally closed contact on the relay. From the other side of the closed contact, it goes to terminal A1 on the contactor. You connect the neutral cable to A2. Now we are going to connect this fan or the motor. We connect the source to the motor. So I'm going to explain the wiring, then we test the circuit. So this is the selector switch. When this selector switch is closed, the sensor is energized. And when we turn on the main breaker for the AC source, current will flow through the closed contact on this R1 to energize the contactor. So as the contactor is energized, okay, the fan or the motor would continue to operate. Now our contactor is energized and the motor is operating. It means that the conveyor is also running. So the metallic object is on the conveyor. So when the metallic object or the box reaches where the sensor is positioned, okay, it will sense it and then the sensor will activate. When it activates, this one is a normally open output. It becomes normally closed and then it will send 24 volt DC to this terminal. So when the sensor is not activated, it is normally open. The moment it activates, it becomes closed. So when the relay energizes, this contact will open and then the contactor will de-energize. Thereby, our conveyor will stop. So when the metal box or the metallic object is taken away from the sensor, okay, this contact or this cable will open again. Therefore, the relay will de-energize and then this contact will become closed again. Then the contactor will energize and then the conveyor will begin to go or operate again. So let's test the circuit. So I'm going to turn on the DC breaker and then the AC breakers. When I turn on the AC supply or the breaker, the contactor would energize and then the conveyor or the motor would operate. So I am switching on the breakers, the DC breaker and then the AC breakers. You see that as I turn on the AC breaker, the contactor is energized and then the motor or the conveyor is running. Now I am switching on the selector switch to energize the sensor. Now the sensor is energized. So assuming the metallic box is on the conveyor coming, so when it senses the sensor, let's see the relay, then the contactor. It starts. Check the sensor here. The light is on, it is activated. So engineers, this is how you use inductive proximity sensor to control an induction motor. If this is the first time you're watching this channel, then I'll urge you that you subscribe. You hit on the subscribe button and then you hit on the bell icon. You choose all to turn on your notification, okay? And then you like the video. You put down your comments and you share the video to your friends, okay? We will meet in the next video. Thank you.